Hi, in this video, I would like to show you how you can use Node-RED to do to implement this statistical test for change detection in time series. So here you can see that our problem is we want to detect the time when uh, the some statistical property is changing for your time series. So let's say that here the mean value is changing. You can see that it's changing several times. And for that, we are going to use the uh, the classic hypothesis test, assuming that we know the real value of the mean. So the real value of the mean is assumed to be known in this method, and then we calculate this statistics. The T student statistic is calculated in which this mu hat is the estimation of the mean, mu is the real value of the mean, sigma hat is the estimation of the standard deviation, and n is the number of samples. So in this case, we are using a window of 400 samples, and if you go online and you try to find calculators for this t value, many sites you can find different calculators, statistical calculators, and in this case, if you put degrees of freedom 400 and the significance level that we are using here is 0.01, so this value will come 2.58. So anytime that this for a given window, if we detect that this statistic, the t-student statistics is greater than this value 2.58, so we will declare that a change of the mean happened in the time series. So just to show you this, here is the flow. First I generate some random samples. Okay, I do some scaling just to have some values of for the mean value and the standard deviation. And I have two states, one is healthy and another is broken. So that you can see that, for example, when one in the healthy state, I have some values of the min and max value of the signal, and then uh, when it is broken, so I will increase the mean in 0.1. So just to show you here, inside this is the main function. Here I am doing the estimation of the mean and the variance of the standard deviation, and you can see that here I am doing the test. I calculated the t-student statistics and comparing again this 2.58, and anytime that this is greater than this, I will change the state to broken. Okay, so just to show you here, for example, so let me reset the state, and you can see that here now the state should be healthy. Okay, and so here you can see the current value of the estimation of the mean, the current value of the estimation of the variance, and the last mean and the last variance. So this is the signal. The signal is going between let's say 0 and 3 point something, and so here it is the healthy state. So when if I click here in this switch, I will trigger the change in the way that the random value is generating, and I will increase the mean of the signal in 0.1. The real, so you can see that the mean of this signal is around 1.7. So I am trying to detect changes of around 15% in the mean value. So you can see that, let's say, wait, for now, no broken state has been detected. So you can see one more time. Let's see. Uh, Anytime that this goes to zero, like for example here, it means that the window is completed and no change has been detected. So let's change now the state to broken and see if it's possible to detect the change in this window. So here it works, it should change to broken. Okay, you can see that it changed to broken. So just to show you that it works, let me reset the state here, and again, if this is working, it should detect again that this window corresponds to the state broken. So you can test yourself. Of course, some problems I have detected. Sometimes you may have some false alarms. Okay, you can see that again it comes broken. Some false alarms, as I was saying, sometimes you may have some false alarms or non-detection, but in general it works fine. So you can test yourself. Okay, bye bye. Of course, I am happy to answer any question about this.